Today for everyone, I'd like to introduce a high-performance, multi-pulse cable fault tester. The instrument consists of 4 main parts. Let's have a look. The first part is this distance meter, mainly to measure the distance of the cable failure point. Let's open it up and take a look. We can look at the interface of the rangefinder. The interface of the rangefinder is the touch screen. It has a waveform analyzer. So let's have a look at our fault pinpoint locator. It has 2 modes. One is the acoustic-magnetic pinpoint mode, and the other is the step voltage method. The pointing instrument should be used with a fault location sensor. This fault location should also be used in conjunction with the probe. Screw the probe underneath, and there's a handle on the probe. Look, just like this. This cable fault locator should cooperate with the fault location sensor is used together. When using it, we need to insert the probe into the soil. There's a signal sensor line here. Connect to this host. The transmitted signal will be displayed on the pointer. This cable high voltage signal generator. It's also a KNDE, and the operation box is integrated. The operation is relatively simple and convenient. Easy to handle and carry. This is a cable and pipeline locator. It's also called a cable profiler. Its purpose is to find the direction of the cable. This cable fault tester is used for the detection of buried cables up to 35 kilovolts and the detection of failure points. First of all, when doing cable failure, we need to measure its insulation, determine whether the cable is a low resistance or high resistance fault. When the low resistance fails, that means the cable is completely cut, fully grounded state. In this case, we only need to use this high-performance cable fault rangefinder. You can find its fault point. There are also high-resistance failure points, means that the cable is not fully grounded. The situation may be that the cable is broken, or the cable is not completely disconnected. We need to use a multiple impulse method, or shock flashover method for testing. To use the multiple pulse method, you need this cable fault locator to find its fault point. When you use multiple pulses, the current coming back picks up a signal, will be reflected on this host, the waveform displayed on the instrument screen for analysis. Now, let's assemble the experimental setup. We use a coupling method first. Set the frequency to 3.2 kHz. Then we make a confirmation. Then a voltage output is performed. And we started looking through the A bracket. And let's look over here. We can see the signal value of the route. And we're moving on. There is a value on the gain side. Remember to be greater than 600.